Hello, welcome back. In the last session, we have seen why memory matters. In this session, we'll see what are the techniques for effective memory management. So, what is a short term versus a long term memory? Short term session memory tracks recent queries, intents, and session specific context. This is critical for maintaining coherence within a single interaction. What is long term memory? Stores historical data, user preferences, and domain knowledge that persists across multiple sessions. This ensures agents can maintain continuity over days, weeks, or even months. So, vector databases and semantic search. Using vector embeddings, agents can convert text data into searchable vectors. This enables fast and accurate retrieval of relevant information from vast knowledge bases. By leveraging semantic search, agents can identify the most contextually similar data points, supporting nuanced and accurate responses. Let's move on. So, there are some more memory management techniques. Next one is called chunking and context windows. When dealing with large inputs like extended documents or long conversation histories, agents use chunking to break the data into smaller, manageable pieces. This ensures the agent can focus on most relevant information without getting overwhelmed by irrelevant details. Next one is metadata and tagging. Adding metadata such as timestamps, user IDs, or categories allows agents to efficiently filter and retrieve information. Instead of searching through all stored data, the agent can jump directly to the relevant tagged information, improving retrieval speed and accuracy while minimizing the risk of outdated or irrelevant responses. The last one is RAG, also called Retrieval Augmented Generation. RAG enhances memory by querying a knowledge base for relevant context before generating a response. This ensures the agent's output is grounded in accurate, up to date information, increasing reliability and consistency in its interaction. Next is the role of frameworks and tools. Modern AI frameworks and agent building tools are designed to simplify memory management. These tools provide seamless integration of advanced memory techniques, including vector database support, metadata management, and retrieval augmented generation. By leveraging these frameworks, you can avoid the complexities of building memory systems from scratch. Instead, developers and non technical teams can focus on refining the user experience and driving strategic outcomes. Framework like LangChain, B, and LangGraph often come equipped with built-in tools to manage both short-term and long-term memory. This makes it easier to design agents that feel cohesive and purposeful, even in complex environments. By mastering memory and context management, you can elevate your AI agents from simple responders to intelligent, adaptive systems that user can trust and rely on for the long term. Memory doesn't just make agents smarter, it makes truly valuable. What are the practical application of memory management? There are few example I can take. First one is customer support. Agents can recall previous interactions, providing seamless support across multiple sessions without requiring users to repeat information. Personal assistance. AI assistants can remember user preferences, schedules, and habits, offering increasingly personalized and proactive support over time. Educational tutors. AI tutors can track a student's progress, remembering areas of difficulty and adapting teaching methods accordingly. Healthcare assistants. Medical AI agents can maintain comprehensive patient histories, ensuring continuity of care and personalized treatment recommendations. What are the future of memory in AI agents? The 4 points I can discuss. Enhanced personalization. As memory management techniques improve, AI agents will offer increasingly tailored experience, anticipating user needs with uncanny accuracy. Cross platform continuity. Future agents will maintain context across multiple devices and platforms, providing a unified experience regardless of how or where users interact. Ethical considerations. As AI memory becomes more sophisticated, addressing privacy concerns and implementing robust data protections measures will be crucial. Cognitive architecture integration. Advanced memory systems will be integrated into broader cognitive architecture, allowing AI agents to reason, learn, and adapt in ways that more closely mimic human cognition. Thank you. See you in next video.